We're going to cover a new topic called Quality Function Deployment or QFD. The learning outcome of this particular topic, basically at the end of this module, at the end of this topic, you should be able to do these two things. One is explain the meaning and steps in QFD, Quality Function Deployment. And the second one is basically you should be able to construct house of quality. Basically, house of quality is the outcome of the QFD. So basically, if you are able to construct the house of quality, indicates that you understand the steps of QFD and the meaning behind the QFD. Uh, Quality function deployment is basically a technique to identify customer requirements and match them with engineering design and performance parameter. So basically, QFD is a technique for customer identifying customer requirement. So basically, if you want to design a product, and when you want to design that particular product, there are two ways of doing it. One is they call it push method. The other one is pull method. Push method is basically looking into the strength of the company in designing that particular product without getting information from the customer. Whereas the pull method is basically to design a product based on customer input, So this is aligned with this QFD approach. So in designing the product based on QFD approach, you identify the customer requirement, and based on that customer requirement, sometimes we call it a voice of customer. Then you define the engineering design and performance parameter of the product to satisfy the customer requirement, right? So basically, that's the concept, the overall concept of quality function deployment. And in doing so, in identifying customer requirement and coming up with engineering designs and performance parameter to meet the customer requirement, basically the exercise of matching the two can be done using the formations or using the house of quality concept. Quality function deployment is actually from a Japanese phrase, which means the strategic deployment throughout all aspects of product of appropriate characteristics according to customer demands. So it's quite wordy. The definitions of from the Japanese phrase is quite wordy. Basically, it's the strategic deployment throughout aspect of product uh, of appropriate characteristics. So basically, this is referring to the engineering design and performance parameter according to customer demand, according to customer requirement. Okay, looking at the history of QFD deployment. So QFD has actually been developed by Dr. Uh, Mizuno, and the first applications of QFD is actually done at the Mitsubishi Heavy Industry in designing the ship at the Kobe shipyard back in 1972. So then the Toyota adopted the concept of QFD, and they implemented in designing Toyota minivans. So they started that in 1977, and when they designed the minivan and redesigned the minivan in 1979, 1982, and 1984, basically they used the QFD concept to actually come to design in improve design, meaning that in designing every individual new model, then basically they got input from the customer, voice of customer, and they built house of quality in defining what are the engineering requirement and design requirement to meet the customer requirement. And by doing so, they actually realized quite substantial startup cost. So you're talking about 20% in 1979. Next version of Toyota minivan, they further reduced the startup cost by 38% and 61% in 1994. So they have a very good success story on Toyota minivan implementation of QFD. Yeah, the other case study that you can find of the implementations of QFD is by Dr. Kausing for Xerox product in 1984. And in fact, QFD can be applied in any industry, whether manufacturing, any manufacturing or service industry. So whether you're offering a product or a physical product, or you are offering a service, you can implement QFD, and basically you get to gain benefits of ensuring that your product design meets the customer requirement, and also reduction in startup cost accordingly. As mentioned earlier, in the QFD method, quality function deployment methods, the most important thing is getting the voice of the customer. So the driving force behind QFD is basically customer dictates attributes of a product. So if you want to design a product, the attributes of the product should be dictated by the customer. Examples, if you are in the area, in the field of, in the market of handphone, right? If you want to design a new handphone, so basically if the customer, based on customer input, the customer said that they want a better camera capability, then basically that's the attribute of the product, which is a handphone should have a camera with a good capability. So it's very important the concept is to satisfy the customer needs, customers satisfy customer requirements. So you need to make sure that your product have a feature that meeting or exceeding customer requirement. So when you ask the customer said they want to have a good camera capability on the product. So you should not design your product just to meet the customer requirement, but you have to exceed the customer expectation. Customer expectation can be vague and general in nature. So as I mentioned just now, so customer might say that, okay, I want to have a camera in handphone that has a good capability, but that's going to be vague. So what's good for camera? So it's up to you and your design team to define that expectations, to quantify the expectations. So you need to be able to quantify it. So what does it mean by good capability? So maybe you can do benchmark with the rest of the handphone out there. Look at the camera capability that they have. So maybe that's your benchmark. So how do you make sure that the camera capability in your phone is better compared to other competitors? So customer expectation must be taken literally, not translated into what the organization desires. So this is quite important. So if you want to adopt a QFD concept, quality function deployment concept, basically you need to take customer requirement literally. If they say they want to have a good camera function capability in the handphone, that means that they want that. They're not looking for maybe a better sound sound system inside the camera, inside the phone, but they want to have a camera. So so it's not, you should not translate customer expectation to what the organization desires. So you should take customer input, customer expectation literally. So this is the concept behind QFD. Making sure that the customer voice is the most important thing, the most important element that you have to take into considerations when you design the product. So this is again, as I mentioned just now, when you design a product, there are two ways. One is pull, the other one is push approach. So if you are doing a pull approach, so you really have to listen to your customer. In a push approach, then you don't have to basically, those company that at the leading edge of technology, then sometimes they design their product using a push approach. So they're introducing something really new, something that the customer don't even think of, because they're at the leading edge of the technology. So that's fine. But if you're decided to use the pull approach of designing a product, and to use a QFD, then basically you need to really pay attention of the voice of the customer and translate the requirement from the customer into product feature and engineering requirement that you want to build into the product that you want to design. So how do you get input from the customer? How do you get feedback from the customer? So there are you can categorize it into two types. One solicited, one is unsolicited. So solicited input is basically you actively seeking information from your customer, from the market. Unsolicited is basically is the informations that you are not actively seeking the information from the customer, but you can get this information from the available sources. So there's examples of solicited customer informations you can get uh, custom customer and market survey. So this is the regular things that we do. If you want to get feedback from the customer, we come up with survey questionnaires and distribute to the market and get the feedback from the customer and from the market that way. The other way to do it is trade trials. Examples, you give you give a free sample of a product and ask people to comment, to feedback on it. So for example, there are many of these activities happening online sale. For example, if you buy something through Amazon, so on and so forth. Sometimes uh, you can get offered. Uh, Sometimes you are offered a free product, but you need to give feedback on the performance of the particular product, what you like or dislike, so on and so forth. So that's examples of trade trials. The other way to get information is basically using a focus group. So focus group is basically a group of people with certain knowledge of the market requirement. For example, if I want to make a product to be used by surgeons during operations, during surgery, right? So what I'll do is I'll gather all doctors that actually routinely doing surgery and get feedback from that particular group. So you assemble them, you have discussion with them, you ask questions, you ask feedback, you ask input. So that's basically one way of gathering information from your customer. So there's also unsolicited way of getting information about a particular product. You can get it from customer complaints. So you can get customer complaints from various agencies on certain product, and from the customer complaints then basically you would know what's the customer requirement going to be for that particular product. So you can gather those informations and basically translate that into the product requirement and also the engineering requirement for the product you want to design. Or you can get informations on lawsuits in a particular field of a product. For example, lawsuit on car failure. So based on that, then you know what is customer looking for and what are the attributes that they don't want and they are really critical of. So based on that, then you can actually design your product, taking into considerations customer feedback and indirect feedback based on the customer complaint and also based on the lawsuits out there. As I mentioned just now, in QFD, the most important thing is the voice of customer. So based on customer requirement and input, basically you want to meet and exceed the customer requirement. So in meeting and exceeding the customer requirement, basically there is a tool called Kano diagram. And this tool is very good tools for you to identify how to meet the customer requirement. So what feature in a product that you need to fulfill to meet the customer requirement, and what are the feature of a product that can exceed the customer requirement. So let's talk a bit about this Kano diagram. So what's Kano diagram? Kano diagram is a well-proven concept. It's a concept, it's a model that promotes customers to select one product or service over another. So basically, Kano diagram is a model to explain why customers select one product or services over the other. So this is the key things in designing product. You want to make sure that your customer, potential customer, buy your product and not other people's product. So the Kano diagram basically contains a pair of axes, x and y axis, labeled satisfaction and performance. So it has two axes. One axis has satisfaction, representing a satisfaction level. The other axis representing a performance level, and it contains three plotted lines: a basic line, performance line, and assignment line. As mentioned earlier, Kano diagram has two axes. So the x-axis, which indicates the performance. So, and at the center of that particular axis, is another axis, is y-axis, vertical axis, indicates satisfaction level. So the performance axis range from poor performance all the way to good performance, and the satisfaction axis again range from low satisfactions to high satisfactions. So this is a basic Kano diagram axis framework. So basically when you talk about satisfactions, this is satisfactions from the customer point of view, and the performance reflects the performance of your product. So the first line in the Kano diagram is basically the basic line. So this is the basic line. So the definition for this basic line is, no matter how good the achievement, it isn't going to impress the customer. The customer expects this. Without achieving this, you aren't even in the market. So this basic line is basically a product, a feature of a product that if the performance of that product is very low, is very poor, then then the set even slightly poor, the satisfaction level will drop tremendously. because this is a basic function of that particular product. And if you excel in that particular performance of that particular feature, the satisfaction level will not increase that much. Because no matter how good the achievement of that particular feature, it isn't going to impress the customer because the customer expect this. Example of this is basically in a car. Then you're talking about performance of the car not leaking during in rainy environment. So if you drive the car in rains, then basically no water will leak inside. So no matter how good you perform in not having a leak in the car, the satisfaction level of a customer will not increase tremendously because the customer expect that as a basic function of a car. But if it leaks a bit, right, customer will not be satisfied. And if you build a car and the car leaks during rain, the rain water can get into the car, then basically you should not be in the market of making a car, right? So that is basically the basic line. So the basic line representing a basic feature that the customer expected. If you perform well in the performance of that particular feature, the customer won't get excited about it because they expect it as a basic requirement of that particular product. The second line in the Kano diagram is called a performance criteria line. So this is the performance criteria line. It's a straight line. Um, um, and the definition for this line is the more of this feature, the happier the customer is. This keeps you in marketplace. So this the line indicating a feature in a product that the more you have it, the better you are at it. Basically, the customer will satisfaction will keep on growing, and this keeps you in the marketplace. Examples of this is basically fuel consumption. So fuel consumption. So the better the fuel consumption for a car, then basically the more satisfied the customer going to be. So as the fuel consumption's performance increase, so does the satisfaction level of your customer, and this will keep you in marketplace. So in designing a product, you need to understand what is the basic feature of a product, and you have to fulfill the requirement of a basic feature of that particular product. Right? For in a car, it must not leak, must have a tire, the steering must be able to control the car. So those are basically basic feature of a car. You must have ignition system. You crank the key once, then the car will start right away. So if you have to crank the key 10 times, only then the car will start, then basically you're in trouble. So that's basic feature of a car. So and you have to fulfill all those features, right? Performance criteria, you have to identify the performance criteria of a car if you're in the automobile business. So it must be, let's say for example, it must be good in fuel consumptions. What else? It must be the entertainment system must be well equipped. So the better it is, then the higher the satisfaction level of your customer, so on and so forth. So you have to list the feature of the basic feature and also the performance feature of the product, so that you have to so that you can fulfill and keep on satisfying your customer. But these two feature will not make you the best will not make your product the best in the market, because for that you need to have that excitement feature. excitement criteria. So to explain that, basically, you need to add the excitement criteria line in your Kano diagram, where this line indicates that the customer doesn't expect this particular feature. The customer is pleasantly surprised, even if the actual achievement is not very good. Sometimes they call this customer delighters, and this will make you a market leader. So you have to be a leader in the market. Then basically you need to identify this assignment criteria. So assignment feature. So for example, in Malaysia, in Pro2, Myvi, right? So you're talking about the car, a price range of 50,000 ringgit Malaysia. So that's quite relatively cheap, right? And the latest Myvi, it has a feature, they call it autonomous braking system, where if you are too close with the car in front of you, then there's a sensor to detect it, and it's actually will brake the car on its own. So having that feature for that particular product segmentations, a car, a low cost car like that, will increase the satisfaction level of a customer tremendously, even though the performance of that particular system is not 100%. But knowing that that particular car, my V, has that particular advanced feature that usually not available in the uh, 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 low priced car like that, then it increased the satisfaction level of customer to a high level. So because of that, then basically it become a market leader in that particular car segmentation in Malaysia. So those are that is examples of the excitement feature that you have to identify um, in your product segmentation. So if you have that feature in your product, then you can become the market leader. So if you combine all those lines together, then basically you have a complete Kano diagram where you have excitement line here. This is basically performance line, and this is basically the basic line. So you have to identify features of your product for all these categories. For the basic requirement categories, then basically you have to fulfill and excel in it. For the performance feature, that you need to keep on improving yourself in it, and at the same time you have to think about the excitement feature, um, to make sure that you can become the market leader in that particular product segmentation. So having this knowledge, then basically you can start to design your product, um, having your customer requirement in mind, and basically you can also ask your customer, when you do a market survey, you can ask your customer what might be the excitement criteria, excitement feature that they are looking for, that might make them to switch from other product to your product, and what are the performance features that they are looking for in a product, and what are the basic feature that must have in a product. So you can design your questionnaire according to this Kano diagram model to get feedback from your customer. Just an example, using a car to explain the Kano diagram. So in a car, the basic feature might be the wheels must start every time you crank the key starter. Performance can be economy, so the fuel consumptions or the performance. You go from 0 to 100 kilometer per hour in how many seconds. So the better your performs, then basically the higher the satisfaction level of customer, and that will keep you in the market. And examples of delighter or excitement feature is, for example, latest in-car entertainment system. So maybe the latest safety system in the car, autonomous driving capability of a car. So that might be a delighter functions, yeah, in a car. Let's look at some of the benefits of QFD. The first benefits found by the practitioners or researchers of QFD is basically customer driven. Second one is reduces implementation time. It promotes teamwork and provides documentation. We're going to go in detail on every single one of these benefits. The first benefits is customer driven. By implementing QFD, it creates focus on customer requirements. So using the QFD approach, you'll be actually forced to focus on customer requirements while designing the product, while thinking about the product. It uses competitive information effectively, prioritizes resources, and identifies items that can be acted on. So if when we go through the one of the tools in QFD, which is the constructions of the house of quality, you're going to see the evidence of this. Basically, when you want to construct during constructions of house of quality in designing a particular product, basically you're going to focus on customer requirements. That's the first thing that you do. And inside that particular tools, it requires you also to do some benchmarking against your competitor, and basically use the competitors data on the similar product and rate yourself in terms of your product performance. So it's kind of like guide you on how to use your competitive informations effectively, and from there then you make decisions where you are in terms of comparing your product against your competitors, and then you make decisions on what feature you want to emphasize, what feature you can put at the back burner, so on and so forth. So that's will be quite evident in the house of quality constructions later on, and it will actually help you to prioritize your resources. So what the house of quality going to do is going to actually prioritize the features that is important in your customer, based on your customer inputs. So it'll tell you, which one is should be number one, should be number two, so on and so forth. So then basically what you can do, then you can prioritize, what feature in the product that you want to design that you want to design, that you should put resources on, so that if you have limited resources, you can put your resources on the important thing rather than on items or feature of a product that not really being considered as important by your customer. So this will help a lot in terms of prioritizing the resources that you have, and it will actually identifies items that can be acted on. So the construction of house of quality using this QFD approach will actually uh, force you to specify a particular items in detail, in quite details, so that you're not talking designing in abstract form, but actually very objectively specifying certain feature of the product that you should work on. So it kind of help you to focus on what's important and what's not important. The second benefits of QFD realized by the practitioners and researchers in this particular area is it actually reduces implementation time. So you're talking about implementation times, about product design and also introduction to market. The reason why it's so because the efforts as being put at the design stage using QFD approach is huge. So you put a lot of focus in the design stage. So because of that, basically your design is quite solid. Looking at the product design from various point of view, based on the customer input. So what it does then, it decreases midstream design change. So because you put a lot of effort upfront in thinking about the design of the product, then actually it will minimize the design change at the midstream. And it also limits post introduction problems. So if you design the product well upfront, then basically you're going to have less problem when you start to introduce the product. So you don't have to do recall or fixes after you launch the product. Avoid future development redundancies. So again, this is as a result of the solid and heavily emphasize on the heavily emphasized design stage using QFD methods. Identifies future application opportunities. So again, based on the customer requirements and based on if you use the Kano diagram concept, then basically you should be able to identify future application opportunities of your products. Something that even the customer don't expect it, but the design team through the QFD methodology will be able to identify future application opportunities of that particular product, and it will surfaces missing assumptions. So this is due to the input that you gather from your customer, because sometimes as a designer, as a developer of the product, sometimes you are blinded with what the customer actually wants from your product. So by having input from the customer upfront, then basically it should surface as missing assumptions in the development of your product. The other benefits of QFD is it promotes teamwork. So the one of the pillar of QFD is basically teamwork. During the when you start to develop the house of quality, basically it requires you to have a good teamwork from various area of the organizations, meaning that usually what happen at design stage, then designer will study it and then maybe have a discussion with engineering, and then so on and so forth. So once the product is designed, then basically you pass it down to the implementer, with to operations, to manufacturing, so on and so forth. But using the QFD concept, the teamwork that actually look at the product design must come from every single department in that particular organization. Should be coming from the designer, from engineering, from productions, from materials, from purchasing, from finance, from manufacturing. So the one of the key pillar in the QFD implementation is actually teamwork. So because of that, this will actually promote teamwork. We're going to talk about this particular concept, I think, in a later stage, in a later sections, where we start to talk about the concurrent engineering concept. Okay, so once the team is there, then basically this team is responsible to actually develop the product, design it, come up with the engineering specification, come up with a material specification, and so on and so forth, right? And need to be done based on consensus. So the decisions from this group need to be done based on consensus. So basically, you need to convince other people in your group that your idea is good. Then if there is other conflicting ideas, then you have to discuss and resolve it. So the decision will be consensus decisions. At the end of the day, so at the end of the design period, then everybody in the team need to sign the documentations of the product design, so that everybody is responsible towards the development of the product, whether they are from design group, engineering, manufacturing, finance, materials, so on and so forth. So it really promotes teamwork. It creates communication at interfaces. So basically, now you're not longer working in silo. No, design group work in design group among the designers. Engineers work among engineers. Only productions work among productions. You know, so due to these multi functional groups in the QFD team, then basically it creates communications at interfaces at various interfaces of the organization. So this actually helps out in terms of it actually facilitate in managing this particular project. So then basically you can cut down in terms of resistance when you want to propose a particular product design, because that particular product design is developed by various functional groups. Okay. It identifies actions at interface. So again, when everybody works together in a team, then basically at a given time, at the same time simultaneously, all functional groups know what need to be done, right? So it's not like a designer did the design, hand it over to engineering need the specification, technical specification, product process specification, so on and so forth, and then pass it to manufacturing. No, it doesn't work that way, right? So it actually happened at one go. Identifies actions at interfaces. So at the same time, everybody in the organizations that responsible and has a stake on making that particular product, from design up to shipping, would know what need to be done at the same time. So actually it cut a lot of lead time in terms of understanding the problem, understanding what need to be done, so on and so forth, right? It creates a global view out of details. So again, it creates a global view out of details. So basically, since everybody is coming from functional groups, then all issues with regards to uh, uh, areas, functional areas, can be addressed at the design stage. So it actually promotes teamwork. For example, if the designer said, I want to make this particular product using a specific equipment, and maybe then those people from production said that, okay, so we don't have enough of that particular equipment, but we have other piece of equipment that can actually do the same function. So can we use that? So basically, the when you look at when during design stage, every functions in the organizations can actually resolve their problem once the product being launched at that design stage. So it will cut a lot of headache once you roll out the product into the productions or into high volume manufacturing later on. So it creates a global view out of details. Right? The other benefits of QFD is actually it provides documentations. So this is the key, because usually at design stage, and then after design stage it passed to another functional groups on so for product development. Usually the documentation will be missing, but QFD forced the same group actually to do the design from A to Z. So because of that, then the maintenance and the documentation is much easier, right? Uh, uh, then you would have documents rationale for design. So you would have documentation on why the design is developed as such. uh, it's easy to assimilate, add structures to the informations, adapts to change living documents, provide framework for sensitive analysis. So basically, due to the QFD methodology and the development of house of quality while designing this particular product, then documentation is there. Documentation is there. It adds structure to the informations, because you know what's the first step you do when you design the product, what's the second step, what is the third step, what are those data that support the first step, second step, third step. All those are in the documentation. Okay, it adapts to change living documents. So because of that, then basically as the discussion of the product design evolve, then basically the development of the house of quality and documentations attached to it explaining it can be kept. So actually you would have ref 1, ref 2, ref 3, ref 4 of the design, and you can actually trace back the changes, and it's become a living document. Yeah. So if you want to trace back the reason for certain decisions being made for that particular product, then you can find it. So it's much easier for you to do post-mortem, or for you to get data on any analysis, and any analysis to decide what the product feature going to be, what the product specification going to be, so on and so forth. So QFD actually forced the team to have a good documentations for the product development. Okay, so just to set things up before we start to look into the house of quality, which is one of the important tools and pillar of QFD. So again, just to recap, so QFD, the three key pillars for the QFD is: one is voice of the customer, means that basically you need to start your design work based on the customer input, and you can get the customer input from various means of data gatherings. You can do survey, it can be solicited, unsolicited. You can do data survey, you can do a focus group, you can do industrial trial, and then you can get it from unsolicited information center, for example, from the complaints by customer on similar product, through the lawsuit, so on and so forth. And we discussed just now some of the benefits of the QFD, and basically most of it is centered towards the good design work being done upfront. And the design work, basically majority of the design work will use a tools which is house of quality, and the team that actually work on the design work of that particular product, through the definitions of the house of quality, must be done by a team, and must be interfunctional team, meaning that the team members must be coming from the various organization functional group in that particular organizations. So again, QFD, there are three main pillars. One is voice of the customer, house of quality, and interfunctional team. We have talked a lot about voice of customer. We have talked about a bit about interfunctional team. We're going to cover this in one chapter called concurrent engineering or quality design. And basically now we're going to focus on the house of quality, which is actually the most important tools in QFD. And QFD is basically an approach that integrates the voice of customer to the product and service development process. So you have to remember that when we go through the house of quality construction, then basically this is what we're trying to do. You know, we're trying to match the voice of the customer based on customer input into the product on and service development process. So the first thing that we have to do in the constructions of the house of quality is actually get the feedback from the customer. Let's look at the house of quality, the overall house of quality diagram. So basically, there are many versions of house of quality. Basically, if you look at the different books, different references, then they will show you a different house of quality diagram. But the difference are quite minor. Maybe the locations of the some of the rooms here are at different locations, and maybe the steps at different steps. But overall, these are the house of quality in general. So basically, we start from step one, which is what's. So this is where the customer input going to be listed, and also we're going to look at the priority of the customer input, what the customer desire. So we're going to put the priority, and the priority of the what the customer desire also coming from the customer itself. So this column, this particular room, what's and also the priority, the voice of customer, and also the priority of the voice of customer. This information can be gathered from the customer themselves through surveys and so forth. You know, there are a few methods that we covered just now. Second, basically, we're going to look at the second step, the third step. The first step is what's fill up the what's room, and the second is we specify the priority for individual customer requirements. Third, basically, we're going to look at how. So this is basically technical or engineering requirements or parameters. So this is the design parameters for that particular product. And this is basically the voice of the designers, the voice of the engineers or designers. Right? So this actually look at the design parameters for that particular product. So once this design parameters has been specified, then move to the fourth step. So this is the relationship matrix. Basically, this is to look at the relationship between the design parameters and the customer requirement to see how aligned is it the individual design parameters and the individual customer requirements. So basically, there will be a matrix here and looking at the two, how and what. Yeah? And basically there'll be a point system being allocated to look at the strength of the relationship between the how and what. So we're going to go that after this in a bit detail. So at the end of this particular step, basically what you're going to have is you're going to have the importance index of every single design parameter here. So if you have 10 design parameters, then every single design parameters will have the importance index. That actually can be used as a guideline to prioritize your resources in terms of what design parameters are very important with respect to its ability to fulfill the customer requirement. So once that's done, then basically we can look at the technical targets. Technical targets is basically is a technical spec. So every single design parameter here, will need to be quantified, and the value for that parameter need to be stated in here at the technical spec. So every single design parameter, let's say for example, engine power. So over here you need to specify what is a horsepower for that particular product. So this will be a technical spec, technical target spec. And then once that's done, then basically you can start to look at the correlation. So correlation is looking at the correlation between various design parameter here, because some of the design parameter, they are positively correlated, some they are negatively correlated. So you need to understand the correlation between the design parameters. Those correlations can be used to actually adjust the technical or target spec such that you can actually balance the effect of the negative correlations between some of these parameters. And lastly, you can look at the competitive benchmark. Basically, this is comparing between your product ability to meet the customer requirement, compared to the your competitors' ability to meet your customer requirement. So for every single customer requirement here, you will see yourself against your competitor where you are. So this can be used as prioritizing what particular area that you are ahead compared to your competitor, and what particular area you are actually behind compared to your competitor. So that information can be used to emphasize what area need to be looked at and put resources on, so on and so forth. So that's basically the overall concept about the house of quality. What I'm going to do basically after this is we're going to go through on how to fill out all these rooms. We call it rooms, and in general, but the nitty-gritty detail on how to do it in terms of calculations, so on and so forth, I'm going to post one video and one journal paper in ULearn for you to go through in detail, so that you can appreciate on how the nitty-gritty detail of calculation, reasoning, so on and so forth being done to construct this house of quality. So please make sure that you watch that video, and also read the journal paper that I supply. So let's look at the first step. So the first step, we have to look at the what and also priority room, which is located here, this area. Right? So basically, the what column is an input from your customer. Input from customer. So as mentioned just now, it can be done through survey, trade trials, focus group, complaints, so on and so forth. And basically what we need is basically customer requirements and their importance. So we request customer to tell us what's their requirement, what do they want, and it should answer these questions. What trait or feature of the product that the customer desire? Example, if you are looking at designing a car, then maybe the trait and desire of the customer could be the car must be fast, good fuel consumption, cheap, so on and so forth. Right? So basically, we want the attributes of the product that the customer desire, and what we do is just we jot down here in this particular room, right? In column wise. And together with that, we need the priority informations for the trait or feature of the product. And this information also should come from the customer, and usually is rated from 1 to 5 or 1 to 9. And sometimes the priority column has two columns, uh, where one of it will have raw data like 1 to 5 or 1 to 10, and the other column is percentage of that particular score over the overall total score, right? And it serves as a weightage or importance for the trait or feature. So so basically that's what the first two rooms are for. The first one is for what voice of the customer, where where you're seeking input from the customer on the trait or feature of the product that the customer desire. And the second house is basically the priority house, where you put the importance of each of the trait or feature that the customer desired based on customer input. So basically, that's the first two steps that you have to do. Let's look at the second step. So second step, before we go for second step, this is I just scribbled down some examples of the first step. So the first step just now, basically on answering the what's from the customer. So maybe the customer want a very fast car, good fuel consumptions, and the car should be cheap, right? Examples. And then this is basically the importance that the customer said, okay, from 0 to 5, then fast is 4, fuel consumption is 3, and cheap is 5. Then next step, basically we're going to look at the how room. How room is basically the voice of the engineers or designers on how you make that particular product. And basically, over here, you have to list down the design parameters of the product. Okay? And this design parameter must be something that's measurable or quantifiable. So, for example, in here, for example, for a car, so you're talking about engine power, so how many horsepower, right? The weight of the car, the manufacturing cost, maybe the safety system, so on and so forth. So this is what you put in here. So this will provide a response to the customer requirement. And we're going to check the fulfillment of the customer requirement based on what we're going to do next step, where we're going to look at the relationship metrics. So again, so the first step just now we look at the what's and priority room. So what's is basically voice of the customer. In terms of the customer should define the feature that they want to be in the product that you make. Examples given here is for the car. Okay? And second step, then you put the priority, the importance of those requirements. So again, both these information should come from the customer. The third step, basically to fill out this how room, which is on top here, this how room, right? So this is basically the design parameters, and the design parameter should be something that's measurable and quantifiable. Examples given here is like engineering power, weight, cost, so on and so forth. So this can be a lot, even if the customer requirement can be many of them, just list them out. And in terms of product parameter design also should be a lot. For example, this is an example, just put 3 for the ease of explanation, right? So let's look at the next step, where we look at how to establish the relationship between how and what. So let's look at the relationship metrics, which is at the center of the house of quality. So the purpose of this particular room basically is to quantify the relationship between individual design parameters. So what are design parameters? These are design parameters. Engine power, weight, cost, and individual customer requirement. Was individual customer requirement? Just now we have fast, fuel consumptions, good fuel consumptions, cheap. Right? And basically we want to look at the relationship between the two, correlate how satisfy what. So we want to look at how the voice of the customer is being satisfied by the voice of engineer, voice of a designer, right? And usually we have to look at the in establishing the relationship between the two, we have to put some marks for the relationship. So use symbolic notation for depicting weak, medium, and strong relationship and the associated marks. So usually we put symbol in here, and that symbol indicates the strength of the relationship between the two, between the customer requirement and the design parameter, that particular design parameters. And usually the symbol that we use is double circle for strong relationship, single circle for moderate, and triangle for weak. And if you don't have any symbol there, meaning that there is no relationship. And there is mark associated with that is basically 9 for strong, 3 for medium or moderate, and 1 for weak relationship, and 0 for no relationship. For example, just now we have engine power. So we have to look at the engine power relationship with all these elements. So example, you want the car to be fast. Does that have a strong, moderate, or weak relationship with engine power? So if it's strong, then basically you put double circle. So that indicates strong, right? Goes for the fuel consumption. So engine power, fuel consumptions, yeah. There should be either moderate or strong relationship, because if engine power is high, then basically it will consume more fuel. Should have a strong relationship. And cheap and engine power. So yeah, I mean, depend on the engine power, it will dictate the cost of the car, but it's only one component of the car. So I'm going to put moderate. So it's going to be a single circle like this, moderate. And we have to do this for all these items. For example, weight and fast. Is there any relationship? Yeah, if you have if the car is heavy, then it's very hard for you to go fast. So there's a relationship between the two, and it should be maybe medium. Maybe I'll put medium. So, or weak relation. Let's put medium. So medium is like circle. Fuel consumption with weight, yeah, there's a relationship, because the heavier the weight of the car, then the fuel consumption will go down. So this is could be a strong relationship, right? So again, you have to do this in a group, and must be consensus. So when you fill up this particular table, uh, uh, this design spec, this is the what's column coming from your customer. So there's not much of discussion on that. But when you try to fill out this design parameters, and also fill up the relationship between design parameter and also the customer requirement, there'll be a lot of discussions and maybe disagreements, so on and so forth. So the integrator, the coordinate the integrator for this particular activity need to play a very important role to make sure that there are good discussions and decision making process happening here, right? Let's look at this. Cheap and weight. Maybe there is some relationship, but not that strong. So maybe I put weak. So weak is going to be triangle like that, right? So I can fill up all this, and basically all this is associated with numbers, with marks. So for this strong relationship is 9, this is 9, and the weak relationship, the moderate relationship is 3 in terms of mark. So once it's done, then basically summations of the mark multiply with the respective priority of weightage of customer requirement will indicate the importance of respective design parameter. So at the end of it, at bottom here, basically you're going to have in the importance index, important index. Basically, this important index is basically a multiplications of this, a summation of the multiplication between the customer, between the design spec, between this what you call it, score, relationship score, and the weightage and the priority or weightage of the particular requirement. So for example, here is this 9 times 4. 9 times 4 is equal to 36. So you have 36 here, and this is 9 times 3 is 27, plus this is moderate is 3. 3 times 5 is 15. Basically the score is 78 here. So you do this for all. So these calculations have many versions. Sometimes what you do is you take this and convert into a percentage, which basically you add this thing up. 4 plus uh, 3, 7 plus 5 is 12. So this will be 4 over 12. This is 3 over 12, 5 over 12. So we take the percentage, and that weightage times this, the weightage times this number, and you add them up, you get a number. So basically, if you do this, all this, then every single design parameter will have a importance index, right? The higher the important index indicates that that particular design parameter is very, very important design parameter, which actually will dictate the fulfillment of the customer requirement for that particular product, right? So basically, if I have limited resources and I want to put the resources in terms of concentrating on a particular design parameters, then I can use this particular importance indicator to actually put my limited resources on specific area and work on that particular design parameter. So this is the relationship matrix. Basically, is to match between the voice of customer to the voice of engineer, and basically to assess which particular design parameters are important in addressing the requirement from the customer. The next room to be completed is a technical target room, step number 5. So basically, this is answering the how much is house measurement. So just now we have looked at the definitions of house, where we put in all the design parameters, right? For example, engine power, so on and so forth. So at the technical target room, basically what we have to do is we specify the individual design parameter technical targets. So this is like design targets or design specification for a particular design parameter. For example, engine power 200 horsepower, weight less than 200 kilograms. So basically, this is where we put in there. And sometimes this can be among the last informations to be specified. So you can put this information sometimes at the end of the activity. the end of the constructions of the house of quality. And this is again, this is a living document, so it can be amended for good reasons. So again, the technical target area will specify specific informations about the design parameter specification. For example, if it's engine power, then this is 200 horsepower, so on and so forth. Let's look at the correlation matrix up here, these particular segmentations, right? So basically, the purpose of this particular correlation is to identify how house items support positive or conflict negative with one another. So basically, the purpose of this particular correlation is to look at the correlation between all the design parameters that we have specified. So you want to see whether there is a positive correlations or negative correlations among the design parameters. If it's positive correlations, then it's not that concerning. But if there is a negative correlations, then something need to be done. You need to find a trade-off for negative items by adjusting how much values, so that you can get to a sweet spot of the design specification, right? And trade-off must be resolved, or customer requirement won't be fully satisfied. So you have to make sure that that being done. Just before we go any further, let me show you how this is being done. And the correlation between among the design parameters can be assigned some weightage. So if it's strong correlation, then you put three pluses. If it's medium correlation, so you put two pluses. And if it's a weak correlation, you put one plus. Same goes if you have negative correlation, strong negative correlation, you put three minuses. If it's medium, then you put one minuses, two minuses. If it's weak correlation, you put one negative sign there. So let's look at examples of this. Basically, if you look at, to make this thing a bit more easier, then maybe we can define a bit the design parameter that we have. For example, engineering engine power. Is it higher the better or lower the better? So this should be the higher the better, right? Weight of the car. So is it the higher the better or the lower the better? I'm not sure. So maybe the lower the better. So you can argue both ways actually. Cost, of course, no, the lower the better. So based on this, then you can actually look at the correlation among the design parameters to see whether it's positive or negative correlation. For example, let's take engineering power, right? So engineering power, engine power. So if engine power goes up, what happened to the weight? We don't know. If we say that if engine power goes up, then the weight will also go up. Then basically you have negative correlation, because if engine goes up, then is bad for weight, right? So then you have negative correlation. Let's say, for example, we have negative correlations and we put it very weak negative correlation, so we put minus in here. So let's look at a correlation between engine power and cost, right? So if engine power goes up, then what happened to cost? Cost will go up, right? So if cost go up, then is bad for cost. So this indicates there's negative correlation between engine power and cost. So basically, then you have quite, we put it medium correlation, because engine is only one part of the car. So we put two negative correlations there, yeah, two minuses. Then we have to go through the same thing. So weight again cost. So if the weight goes up, so does the cost. If the weight goes down, so does the cost. So this is basically have a same same correlation. So this will be maybe positive weak positive correlation between the weak and between the weight and the cost. So I put there one plus, right? So this is how you fill out this particular area to indicate whether there is a positive correlation or negative correlation among the design parameters. And if you have the negative correlation as such, engineering power and cost, so this is quite medium negative correlations, right? So whenever you want to think about increasing the engine power, then you know that the cost will go up. So that's bad. So you need to come up with solutions, trade-off on how to resolve that. So this will help you to look at the correlation among the design parameters, such that if you increase one design, if you improve one design parameter, what would happen to other design parameters. So there are two consequences of negative correlation. One is, the first consequences is to redesign the product in order to limit the trade-off. So if the negative correlation is too huge, the impact is too much, then maybe you want to look at the redesigning the product. So design parameter need to change somehow. The second consequences is to determine the optimization target, in which the design trade-off are included with their relative importance to the customer considered. So the other way to do it, rather than redesigning the whole thing with the new design parameters, then basically you can find a trade-off. And usually this is what happens. You find a trade-off between the two, for example, between engine power and cost. So you have to define the trade-off between the two, so that you can meet the customer requirement and set the parameter setting in terms of target, technical target spec at the sweet spot to satisfy the customer, and also to satisfy the customer requirement, both in terms of engine power and also cost requirement. Right? So the last segment that I'm going to cover today is basically the competitive benchmark rule, which is this particular portion of the House of Quality. The competitive benchmark helps to identify the current best-in-class design, as well as the strengths and weaknesses of each design. A weighted scale is applied to the system. So basically in here you can use a weighted scale 1 to 5, is maybe 0 to 5. So this is 0 to 5. So 5 is the best, 0 is no marks, right? So will indicate your product ability to meet customer requirement relative to your competitors. So this is how you fill up this. So this is basically the what here, so the customer requirement for that particular product is, for this case, is car, fast, fuel consumption, good fuel consumption, and cheap. And basically you can compare your product in here in competitive benchmark by making this kind of column. So X is your company, your product. You have competitors 1, you have competitor 2. Then you put your score. So you can get this information, you can fill up this information based on your own technical judgment, or you can get customer or market to come up with the scoring, right? So then you can look at fast, fast car. So you can compare yourself and your competitor. So you give marks here. So let's say, for example, for your product you put maybe 3, not so fast. Competitor 1 has a very fast car. Competitor 2 is having a very fast car. Fuel consumptions, maybe your car is known for to the specification is good in terms of fuel consumptions, better your competitor, maybe 1 and competitor 2. So maybe this is scoring of 3, this scoring of 4. And in terms of price, maybe maybe it's about the same. So maybe this is 3, this is degree, this is 3. So basically from these informations that you can actually look at your results. So you can see that the best in class for this particular product is basically for fast car. You're talking about competitor 2 and competitor 1, so you are behind here. You are behind here. The in terms of fuel consumptions, you're way ahead compared to your competitor, and in terms of price, you're about the same. So using this information, then you can make a decisions in terms of what do you want to emphasize on your product, what's your marketing and market segmentations target, so on and so forth. Then you can make decisions in terms of to pay attentions to this competitor, or you are willing to stay as it is against your competitor, and you think you can win with regards to fuel consumption performance. So basically this is where you make that decision. So if you think that you want to put more emphasis on fast because you're behind, right, then you have to look at the design parameter that actually supporting fast, and put more emphasis on those area. Right. So you can see, having these informations, then you can make the strategic decisions in terms of where you want to put your resources in order to satisfy your customer. Okay, in summary, to build a house of quality, what you do is basically identify the customer wants, basically what the customer input with respect to the feature in the product that the customer wants. Once you know that, then basically you need to identify how to satisfy the customer wants by developing the design parameters. Once you have the design parameters, then you establish the relationship between the customer wants and product house. So basically, this is where you put the rating, the relationship rating between the individuals, design parameters, and the customer specifications, what customer wants. And then once you get those numbers, then you develop the importance rating. Then by then you should know what design parameters are important relative to others, right? And then you start to evaluate the competing ideas and concept. This is looking at the correlations among all the design parameters, so that you can pay attention on the negative correlations design parameters, and do a trade-off to make sure that you satisfy the customer requirement. And lastly, you do benchmark and compare your product against your competitor. Study where you are and make decisions in terms of whether you want to actually be ahead of a competitor on certain customer requirements or not. So basically, this is the summary of on how to construct a house of quality. But ultimately, you choose the design, not your customer. So you have to make sure that the end product meet your customer requirement, because the decisions of the design is on your hand. So I didn't go in too detail on how to construct the house of quality lines on how to do that, because this is one of your case study that you have to do on your own. So you need to be able to construct the house of quality on your own, based on the case study. So in order for you to be able to do that, then the detailed descriptions of house of quality constructions, you can get it from these sources. One is the video. So this is the YouTube video, which I think is quite nice. I mean, it was conducted for a class in MIT. So it's quite nice examples on how to construct house of quality. So watch that video. And the other thing is I also upload a journal for your reading assignment. So this journal is also a case study to use house of quality to design a product. So which is impeller. So basically with these two additional resources, we should be able to understand how to construct house of quality in detail. Okay. So that's the end of our lecture on quality function deployment.